everyone, and welcome. So today, we're diving into something that's super critical, but, often gets overlooked. We're talking about the security risks hiding in all the third-party components that your AI systems rely on. It's this whole chain of trust, and honestly, it can be dangerously easy to break.
So, here's how we're going to break this down. First, we'll get into the hidden risks lurking in your AI supply chain. Then, we'll look at some major security breaches to see what we can learn. And finally, we'll get practical and cover the key strategies to really lock down your dependencies and APIs. Modern platforms, especially in the world of AI, you just don't build them from scratch anymore. They're all standing on a foundation of third-party tools. But as we're about to see, that foundation can be, well, pretty fragile. Seriously, I want you to take a moment and really think about this. Because while you're focused on writing your own amazing code, your AI is quietly leaning on this massive external ecosystem. And guess what? Each one of those dependencies is a potential door for an attacker to just walk right in. And just look at this. It gives you a sense of the scale we're dealing with. Your AI core is connected to so many external pieces. We're talking about open source libraries from places like PyPy or Hugging Face, data providers for your training sets, cloud APIs, even the little SDKs you use for authentication and analytics. Every single connection expands your potential attack surface. So what happens when these things aren't secure? Well, attackers get a direct line into your entire system. They can poison your training data, making your model unreliable. They can swipe your API keys and secrets. They can inject their own malicious code. The fallout? Oh, it can be absolutely catastrophic. And look, this isn't just theory, right? Let's talk about some real-world examples where this exact supply chain broke down, leading to some massive security incidents. Remember the SolarWinds attack? It's a classic, infamous case. Attackers managed to inject malicious code into a perfectly legitimate trusted software update. And the result? Over 18,000 organizations were compromised. Just think about that number for a second. They never saw it coming. So the huge lesson here is that trust can't be a one-time, set it and forget it kind of deal. You can't just onboard a vendor and assume they're going to be secure forever. Security is a process, and it needs constant, continuous verification. Then you've got these malicious packages popping up in the Python package index. They call it typo squatting. A malicious library is named something very similar to a real one, hoping you'll make a typo when you install it. And its only purpose? To steal your cloud credentials, your API keys, everything. So what's the takeaway? You've got to treat every single open source library with a healthy dose of suspicion. Basically, treat it as guilty until proven innocent. That means you check its integrity, you pin it to a specific version, and you are constantly scanning it for new vulnerabilities. And then there was the CodeCov breach. This one's wild. A single compromised script buried deep inside the development pipeline, the tools used to build and test software, was silently leaking sensitive secrets for months and months before anyone even noticed. And this is what's so scary about that one. The risk isn't just in the final product you ship to customers. It's hidden deep inside your development process. The very tools you trust to build your AI can be turned against you. Okay, so we've seen the dangers, and yeah, it's pretty scary stuff. So now for the important part. What can we actually do about it? How do we start forging a stronger, more secure supply chain for our AI systems? Well, it really starts with these 3 fundamental steps. First, you've got to use an SBOM, a software bill of materials. Think of it like an ingredients list for your code. Second, you scan that list for known vulnerabilities or CVEs. And third, you create rules to just block any unverified or unsigned packages from ever getting in. It's a powerful framework for vetting everything. All right, so beyond the libraries you're pulling in, the APIs connecting your services to the outside world, that's another huge weak spot. They're literally the lifelines of your platform, and you have got to reinforce them. So let's just look at the difference between doing it wrong and doing it right. Instead of leaving your API calls wide open, you need enforced rate limiting to stop abuse. Instead of using API keys that last forever and can be stolen, you need to rotate them automatically. And for authentication, you move away from weak stuff and use strong protocols like OAuth 2.0 or MTLS. Look, these controls aren't just nice-to-haves. They're absolutely essential. You've got to enforce rate limiting, use strong auth, and apply the principle of least privilege, meaning a key only has the exact permissions it needs and nothing more. This is how you build a real fortress around your APIs. Okay, let's tie all of this together.
Why is this so fundamentally critical for AI platforms specifically? Well, it really gets to the very core of trust itself.
Because with AI, trust is this cumulative thing. It's not a single point, it's a chain. And a single failure, a single weak link at the very beginning of that chain can cascade all the way to the end and lead to a total loss of trust in your entire system. It all starts with the data, right? If your training data gets poisoned because of a weak integration with some external provider, your model is going to learn all the wrong things from day one. You know the saying, garbage in, garbage out. And that, of course, leads to the next domino falling. A compromised model will inevitably start making flawed, biased, or even malicious decisions. It's a direct consequence of that initial data poisoning. And then, the final blow. If your APIs are insecure, those bad decisions or stolen data, that's when it hits your customers directly. And that is where trust is completely shattered. And winning it back, almost impossible. So at the end of the day, you can't just treat supply chain security as some operational checkbox on a compliance form. It is fundamentally inseparable from your ability to build an AI product that people can actually trust and rely on. And really, this is the ultimate takeaway. True security in the age of AI means you have to extend your vigilance way beyond your own code. It has to cover every single component, every vendor, and every API in your entire ecosystem. Because the chain is only as strong as its weakest link. Simple as that.